Hey all, welcome back. So in this one, what I want to do is I want to put in something called Docker, and I want to use that for both the front end and the back end. So Docker it's a containerization. So the way that you can think about that is we used pipenv to manage our dependencies right here. And so Docker is kind of like the next level of that because pipenv it'll manage all your dependencies, which is great. So other people can install all the dependencies from this file here. But that doesn't solve the issue of what if they have Mac, what if they have Windows, what if they have Linux, etc. Another example that this would solve too is if you remember back for to install Kaleido, what we actually needed to do is we actually needed to use like apt-get to install it, that's not a Python specific command. That's to install something on our WSL. So if somebody else installs this here, they're still going to need to actually install Chrome to be able to do that. So if we use Docker on the other hand, we can put commands in the Docker file to have them automatically install that. And what I want to do is use it for both the front end and the back end so that they can be independent and each of them can have different dependencies, which will just help us separate out things a little bit more so we can get this more deployment ready, I guess. So with that in mind, let's get started. Okay. So what we can get started with is we can install the dependencies into the individual containers. So one way that you can do this, although we're not going to do this and I'll show you why, is pipenv does have a command called requirements, and we can put that out to like backend. So we want to make a requirements file so that we can just install this with pip, so it doesn't rely on the virtual environment. So we can do that, and so if we open that up, so that's a lot of stuff right there. And what I ultimately want to do is I want to be able to separate out the front end and the back end. Um, so the way that we're going to do this is we're going to do this a little bit manually, which we can do because there aren't that many dependencies. So we can just manually look through this list and just make the requirements.txt from here. So we'll do that. We'll start out by making requirements.txt on the back end. And so what we're going to want is we're going to want fast API, and we use standard, remember, and we want duckdb. That's it. Not too much there. So then we'll also make a requirements.txt for the front end, and we'll go back and look at this file here, and we want move this over to this side, and we want Streamlit, and you can pin versions too by saying like equals equals and then putting a version like 1.0.0 or something like that. But for this purpose, I'm not really gonna worry about that. But for more of a production grade application, yeah, that might be a good idea so that you don't accidentally install like the latest version of something and it ends up breaking something that you're working on. So, okay, so we need the stats model. We'll keep out the PyTest because I envision us still using pipenv at least for the time being to end up running the tests. So we'll leave that out. Streamlit AG grid kaleido, and that should be it. So we'll go ahead and save that. So what I want to do next here is I want to put in the actual Docker files in here. So first off, let me show you that it's literally a file called Dockerfile, and you see our extension, like the icon actually changed when we type in Dockerfile, because Dockerfile is something that is actually recognized because it's used in so many projects. So Docker containers they're just kind of like bare bones containers. Like, they don't have basically anything installed in them. So we need to actually install Python to do that into our container. And to have Python available in our container, it actually needs to use another container that has Python in it. So this is where a website called Docker Hub comes in. So this is where a lot of public images reside that you can just use Docker commands to install. So I have pulled up the official Python Docker image here. So you could actually, once you have Docker installed on your machine, you can literally do this and it'll just pull a Docker image and you'll have it available to you. So if we pull over the website again, so this is where I got the command for right here. So we can use one of those, but if we scroll down on the page, this gives you a sample Docker file, and we'll use that to get started here. So you can see it's saying from the Python image, and then what it does is it sets a working directory, which is where all your data and everything is going to reside, and where you're ultimately going to copy everything into, all the source files and everything. And then you go ahead and it copies your requirements file. See, it even assumes that you have one, and then it does a pip install of the requirements file. You can see here that has this no cache directory flag on it. So by default, when you pip install something, you get a bunch of cache on your system, which helps to speed up installs in the future. But that's not actually needed in a Docker image, since Docker is meant to be brought up and down all the time. So that's why the no cache directory is used. So then we're copying everything from dot to dot. So basically what that means is you copy everything in the current directory to what's in the working directory. So that's where it copies all your source files and everything that it reads. And then it runs a basic command, and this is just Python and then whatever the name of your actual script is. So this is a great starting point, but we do want to edit some things here. So for example, in this virtual environment here, we're using Python 3.10. So we can do that same thing in the Docker file. And then we want to use something called, actually, if I bring back up Docker Hub onto here, where is it? I also should zoom in a little bit on that. Here, the Slim versions. So Slim is typically used for, it doesn't have the full Python version in it, which, I mean, the full Python implementation that comes with like setup and wheels and just a bunch of other stuff that we really don't need, and it just ends up bloating the image. So typical best practice is to use Python, the slim version, when you're in a Docker container, and that way it gets you just what you need, Python, and it gets you pip so you can use that. Okay, now a couple of other things that we want to do is this is going to be for the fast API server, right? So this runs on a port. So in Docker, the way that we can do that is we can use the expose command here and then put the actual port that we want it to run on. And then another thing here is that we can use like cmd python ./script.py like that, instead of having like this this JSON structure here. Docker accepts both of them, but the recommended thing to do, and I'll admit I don't completely understand why, it's something to do with signal processing, and it's more efficient to use this like JSON-like syntax. So we're going to do that. So the way that we'll structure the syntax then is we'll basically just copy and paste everything here. So do basically everywhere there's a space, we want to put a new string into this list here. So uvicorn routes.app, and then we're actually going to keep out the reload for right now. And then we'll do oh, these have to be 2. And then oops, just a comma here. So just a couple more housekeeping things here. I typically like to just use /app for my working directory. It just helps me keep that in mind. And another thing that Docker allows is it allows a command called health check. And what health check does is on an interval, it'll run a command. And if it doesn't pass, then it considers the app unhealthy, and then it can take actions based on that. So what we need to specify then is we need to specify first the interval, which is going to be equal to 30 seconds, and then we'll give it a timeout of 30 seconds, because what we're going to do is we're basically going to visit a web page within the app, and if it times out, then we're going to retry up to 3 times, and then we'll put in a backslash for a line continuation, and we'll continue on the next line. So we want to run a command, and we're going to run a curl command, which can basically read a web page and so get the status of that. And it's going to be localhost port 5000 and then /docs, because that's going to be the actual Swagger docs. So that's it, and then we're just going to, so this -f flag means fail silently. So if it can't reach this page, then it's just going to fail. And then so these double pipes right here it's an or statement. So if this fails, then it's going to execute the second part of this, which we're just going to do in exit 1, and that's just going to exit the Docker container, so it's going to bring it down. So that is the Docker file for the backend. Now we want to also do a Docker file for the front end, and since this one is pretty similar, I'm just going to paste what I have on the keyboard. So it's basically the same thing. We're taking the same version using the working directory, copying the requirements into it, installing, copying everything. We're using port 8501, so that's our Streamlit port. For the health check, the start period, I should actually probably have this on the back end too. So this start period is basically for, it waits 5 seconds for the app to actually, that gives it time to actually start up before it starts doing its health checks. Otherwise, it's just going to run it right off the bat and declare it unhealthy. So we'll do that too. And Streamlit has, it also has a health check endpoint that you can use as well. This SD core, and then we're just doing a command to run Streamlit. So with that, we can move on and we can just create what I want to create here, which is Docker Compose. So Docker is great. That's a way to run these individual applications in a containerized environment. But what you want is you want something to actually be able to orchestrate everything, so that's what we'll create now. For the sake of time, I also have this on my clipboard, and I'm just going to paste it in. So what this is this actually declares the services that we're going to be running. So we're going to have two, both a backend service and a front-end service. So the backend service that's just going to look in the backend directory that we have on our host machine and look for something called the Dockerfile, and that's what's actually going to instruct it. And then this port here this is going to be mapping. So if you remember, we did expose 5000 here. So back to Docker Compose. So what this is saying is 5000 on the host machine is going to map to 5000 in the container. And then, so the front end is pretty similar. We're just looking in the front end directory and we're mapping 8501. And then what these volumes are doing is this is basically just mapping it so there's kind of a two-way communication between the backend and the app directory that we're creating in the container, so that the container can write files back to here, and we can write files over to the container. So the way that we can run this then is we can use a compose command specifically. So we want to compose is an extension to Docker, so we want to run docker compose and then up. So that just looks for the docker compose.yaml file that we have, and then we want to add a --build, and this is going to build whatever we have. So okay, so it is building. So I haven't hit any errors yet. We will see what happens. Alright, so it finished building, so we do have some output now. So we can click that, and I can bring it over, and as expected, there is an error in it, but at least we got the containers to build correctly. So in the next one, we'll take a deeper look and see what's wrong with these app errors. So thanks for watching.